Basically, the fuse is just a really thin piece of wire. So you've got the earth wire, you've got the live wire coming up through the wiring of the house into the plug socket. Then you push the plug in, and the pin connects the live wire that's in the wall to the live wire in the cable. And then the cable carries on to the appliance. But inside the plug, where that connection is made between the live wire in the wall and the live wire in the appliance, we just deliberately place a really, really, really thin piece of wire just in a gap in the live wire. So it's still a wire, it still conducts, and if everything is behaving as it should be, then everything works. But the reason that we include a thin piece of wire is because wires get hot when you put too much current through them. And if we make this little piece of wire thin enough, then as it gets hotter and hotter and hotter, if the current gets too big, suddenly it melts. And when it does melt, it breaks and the current can no longer flow in the live wire. So the fuse is a deliberate weak point that we engineer into the live wire, just in case the current ever gets too big, which generally isn't a good thing, as we're about to see, and then it just kills off the live wire so that no current can flow. This will mean that when you come to use your appliance, it just won't work. But rather than get irritated by the fact that it doesn't work, you should be pleased because your appliance was trying to kill you and now it isn't. So let's have a little look at how it does that. Okay, so one way in which the current could get very, very high is if your device is trying to electrocute you, or if in fact succeeding in electrocuting you. So I've got a little video here, but I've put next to it just to make the point that the people in the video are quite clearly morons and not long of this world. You are not morons. Please do not do this at home. Okay, let me just switch to what I am sharing with you. Okay, so that's what happens when you put your knife in the toaster. The big explosion of the toaster was due to the fact that a very large current was momentarily flowing through that toaster, and it made it get very, very hot. So in that situation, the electric shock would have continued to happen until something broke, in this case the toaster. But generally speaking, it's possible to get an electric shock, as we spoke about yesterday, where you clamp your hand as your muscles contract onto the thing electrocuting you, and you'd quite like that electrocution not to carry on longer than it needs to do. So the fuse will cause an electric shock to stop once it has begun. But the thing is, where's my mouse gone? The fuse takes about half a second to melt, and during that half a second you can quite easily get yourself a lethal electric shock. And so you must always remember that the fuse isn't going to save your life. You're still going to get an electric shock from the appliance. All it'll do is stop the electric shock from going on for very long, which I guess is a good thing in one way, but it's not good enough. What we want is for the electric shock to not happen in the first place. Okay, so let's have a look at another reason why the current might get too hot. Okay, so here's your toaster. You're used to the fact that you plug your toaster in and you push the little handle down and the bread gets hot and it toasts and everything's great most of the time. But it might not. So let's have a little look at reasons why not. So just before we do, we need to know how a toaster is wired up. So there's the 3 wires coming into the toaster, and the live wire in brown and the blue wire in red. Those are the wires that are connected to the heating element inside the toaster, and they make the heating element get hot. And this is usually the only part of the toaster that will be connected to the live and the neutral wires, the heating element in the middle. However, Toasters get banged often. You're constantly pushing the handle down. Sometimes you pick the toaster up to shake the breadcrumbs out of it. And so the toaster does move around from time to time, and it is possible that the live wire can become detached. Usually if it's not been engineered very well. And the live wire can come to be resting against the metal case of the toaster, which means that the metal case is now connected to 230 volts. And then you come along to get yourself some toast, and you touch the metal case, which is now at 230 volts, and you get electrocuted. That's going to trip the fuse, but you've already been electrocuted, and we've already said the goal here is to prevent the electric shock in the first place. So what we want is some kind of safety feature that as soon as the live wire becomes detached, trips the earth wire instead. We need something else to melt the fuse, not your hand. So what we use instead is the third wire. It's called the earth wire. And the earth wire usually doesn't do anything at all. It's actually connected inside the toaster to the metal wall of the toaster. And you hope that for the entire existence of the toaster, the earth wire never does anything at all. However, if your live wire were to become loose and touch the metal case, it will immediately conduct a current through the metal wall of the toaster into the live wire, into the earth wire. And it's called an earth wire because if you follow it all the way back to the plug socket and then through the wall of your house, it ends up in a big spike stuck in the ground under your house. When the builders built your house, they buried a big metal pole in the ground under your house. And the earth wire is literally connected to the earth. And the earth doesn't mind a little bit of an electric shock. And so if you allow the current from the live wire to flow through the earth wire into the ground, that will result in quite a large current flowing through the earth wire and the live wire, and that large current will melt the fuse, which means when you come to use your toaster, it just won't work. And like I said, rather than getting upset by that, you should think to yourself, this is good. My toaster was trying to kill me, but the fuse wire has saved me. Okay, so fuses are little thin bits of wire, and they do break from time to time. So it is a good idea to pop the fuse out of the plug and put a new fuse in, just to see if it was just an old broken fuse. But if you put the new fuse in and the new fuse immediately melts, you need a new toaster, or you need to get an electrician to fix your old toaster. I've put on there as well, it's not just about electrocutions. You might find that a piece of wiring inside your TV comes loose overnight while your TV's on standby, and that could cause a big current to flow inside your TV. A bit of your inside of your TV could get hot. It could catch on fire. Plastic's reasonably flammable, the back of your TV maybe. And then suddenly you can have a house fire while you're asleep. So again, the fuse will melt in those situations and prevent that from happening. So it's not just a future electrocution that the fuse can prevent, it's also house fires as well. And since we've started using fuses and earth wires, there have been much fewer electrocutions and much fewer house fires. Really, it does come down to morons now sticking the knife in the toaster without unplugging it first. Okay. There it is, nestling inside the plug. So you can see that the live wire comes into the plug here. This is the back of the pin that's going to plug into the wall. So that's where the earth wire connects. And then immediately the live wire connects. And then immediately we've got the fuse before the live wire carries on through the cable into the house. So there's the weak point there. There's the thin bit of wire inside the fuse. We've got a couple of metal connectors on the ends to make the connection with the holder inside the plug. And then this is a glass fuse, just so you can see the wire, but usually we make them much more cheaply using just a cardboard wrapper around it. You'll have noticed that the last fuse and these fuses have got numbers written on the side of them. These are the currents at which the little wire has been designed to melt at. It's called the rating of the fuse. In the UK, you can buy fuses from the supermarket. You don't have to go anywhere special to buy it, and they cost pence because they're mass produced. But the only reason that they get to be mass produced is because pretty much in the UK, we only mass produce 3 types of fuse, 3 ratings of fuse. So the 3 amp, the 5 amp, and the 13 amp. It is possible to buy other types of fuse, but you have to spend a little bit more money because they aren't mass manufactured the way that these 3 are. So if you need a fuse and you pop down to Sainsbury's or Tesco or something like that, it's likely that it's a pack of 3 5s and 13s that you'll find. Which means that every device in your home is fitted with either a 3 amp, a 5 amp, or a 13 amp fuse. However, all the things in your home will use different currents. So your light bulb will use less than 1 amp, whereas your toaster really will be using 10 amps, something like that, 10 or 11 amps. We just have to make do. The safest fuses are the ones that are the next one up that you can get your hands on from the normal working current of a device. So if you know that your toaster uses 11 amps, then there's no point putting a 3 amp and a 5 amp fuse in it because they melt at 3 amps. So every single time you turn your toaster on, the fuse will melt because the toaster uses 11 amps. What you need to do is fit the 13 amp fuse because 11 amps is less than 13 amps. So when the toaster's working normally, it'll only be using 11 amps and the 13 amp fuse won't melt. But then if anything goes wrong, like a moron visits you and puts the knife inside the toaster, then that'll cause a current bigger than 11 amps and then the 13 amp fuse will melt. It would be safer to have a whole load of different fuses so that you could make sure your fuse was much more closely matched to the normal working current of the device. But to be honest, it doesn't make a great deal of difference. And you'll see why in a minute. So those are the 3 fuses you have available to you. Always fit the right one, which is the one that is just above the normal working current. Okay, this is why we're not too worried about the fuses anymore. They are still in our plugs because they are still an important safety feature working with the earth wire. But actually, in modern homes where the wiring has been done in the last 20 years or so, you've got one of these boxes on the wall of your house somewhere, maybe in your garage or under your stairs or somewhere there is a box like this. And each one of those switches, I can't actually see my own mouse on the screen. Each one of those switches there is a resettable fuse. So these resettable fuses don't have a melting wire inside them, and they work by a different technique, and they are much faster than an actual fuse which has to melt, which means that they're somewhat safer. They're much more likely to prevent an electric shock in the first place. And also they don't need to be replaced. You just push the switch, just switches off and you just switch it back on again. So you don't have to replace the fuse. Nothing has melted with these resettable fuses. So they're much more sensitive and they don't need replacing. And they will be responsible for a whole area of plug sockets in your house. So you might have a switch for all of the downstairs plug sockets and everything plugged into them, another switch for the upstairs plug sockets, another one for the downstairs lights, and another one for the upstairs lights. So your house will be zoned, and each bit of the house will have its own switch. You can also use these things when you need more than a 13 amp fuse. So for instance, your power shower, or if you've got a really big oven, they might need more than 13 amps. So you can run cabling not to a plug socket, but actually run a cable all the way from the power shower in the walls of your house, all the way to this box, no plugs involved. And you can just cable the power shower straight into this box, and the power shower will have its own dedicated resettable fuse. One of those switches will just be for that power shower and nothing else. So if you haven't seen one of those boxes, go hunt around your house after this lesson, see if you can find one, but don't go turning any of the switches off because something in your house will turn off if you do. Again, like the fuse, occasionally they can trip, they can flick themselves off. So if you find that something doesn't work in your house, you can go have a look at this panel. It's called a consumer unit in your house, and just check if one of the switches is off. And if it is off, you can switch it back on again. But if it immediately turns off, then there's something wrong in your house. Something plugged into your house is dangerous. So you need to either work that out for yourself or get an electrician to come in and tell you what's going on. Often they're so sensitive these days that often they can just trip if like a bulb blows. You know, you turn on a light switch and a bulb blows, that can be enough of a surge of current to trip one of these really sensitive switches. Usually it's just enough to replace the bulb and then you can turn the switch back on. Okay, a couple of last little things to note. It is possible to have plugs that don't have fuses and earth wires in them, and that's because these things are only really required by devices that have the potential to electrocute someone or burn the house down. And there are some devices in your house that might be just entirely plastic on the outside. You might have a toaster that's entirely plastic on the outside, in which case there's no real possibility of touching a bit that's become live and is sitting waiting to get you. Or a lamp. You know, there's no real possibility of a lamp burning down your house. The worst it can do is the bulb can blow. So quite often for devices that can't electrocute you and can't burn down your house, we don't bother to put an earth wire inside them and a fuse, because it's just a waste of money to add that extra expense to the manufacturing process. So you will find around your house that there are some devices that don't have an earth wire in them, maybe not even a fuse either. There are even some countries in the world, quite large countries actually, that don't have any earth wires and fuses. They just make sure that nothing bad can happen by over-engineering all their devices. So say you want a nice shiny aluminium kettle to look nice in your kitchen. Well, actually in some countries, it's a plastic kettle wrapped in aluminium. That layer of plastic underneath the aluminium means that you can't get electrocuted by the kettle. That's called double insulation. So yeah, some countries don't even use fuses or earth wires at all. And just so you're aware, you can probably go find the nearest lamp in your house, and you'll probably find that the cable on the lamp is very thin compared to any other electrical cable you've got in your house. And that's because that's an example of a device that doesn't have an earth wire in it. And because it doesn't have an earth wire in it, it's a little bit thinner, the cable. So it's called 2-core rather than 3-core cable. Okay, take homes from this presentation today are this slide really. You need, no, not that slide. Yeah, that slide. You need to understand how it is that the fuse and the earth wire together are responsible for increasing the safety of devices. So in terms of making notes from today's lesson, that's the slide that you need to have. And then a little note after it, just to say that fuses have ratings and you need to fit the one that's just above the normal working current. So those two slides there are the notes that you need to write from today's lesson. And this presentation is on Google Classroom, and you'll be able to open it up in a minute and make those notes if you haven't done so already. After that, I know that I didn't give you very much time after yesterday's lesson to maybe make the notes from yesterday's lesson. So if you didn't quite get a chance to draw a picture of a correctly wired plug, please do that. And then I'm pretty sure nobody will have found time to answer those questions yesterday. And even if you did, quite a lot of the questions talk about what we've just spoken about today rather than yesterday. So when you finish making notes from today's lesson, as a minimum, could you please answer questions 1 to 4 from this PDF page? And that's on Google Classroom as well.